Hi, I'm Andrew from the Glaser Tutoring Company. Today I would like to teach you how to use the graph to write an equation for this rational function. So it turns out that there's two important things we got to focus on. What are the intercepts? What are the asymptotes? So there's two types of intercepts. Let's focus on that first. You got x and y. Remember, the x-intercepts are just where the function crosses the x-axis. So it only crosses the x-axis here. I'm going to assume that this goes on. What they meant to do is kind of drag it on and on and on forever here, and it's never going to intersect anymore. All right? It asymptotically basically approaches the x-axis. The only place it crosses the x-axis is here, but if you look closely, I mean, to my eye, it looks greater than 2. But the problem is, how much greater than 2? 2 point what? It's really hard for me to tell. 2.1? 2.2? You know? So I'm just going to assume that it is 2, okay? If you disagree with me, I wouldn't disagree with you. But just to make our life easy, because I don't really know what it should be, it's impossible to tell, I'm just going to round it to 2. So our x-intercept here is going to be 2. So we're going to write 2 comma 0. That's the coordinate. That's the coordinate for that point, right? The y value is 0. All x-intercepts have a y value of 0. Then we're going to focus on the y-intercept. And the y-intercept now is going to be where the function crosses the y-axis. This looks a lot easier to me. That should be a negative 2. So remember, all y-intercepts have an x value of 0, and then its coordinate should be a negative 2. So that takes care of that. Then the asymptotes. Now on the graph here, they're drawn in nicely, though that's what the red dashed line represents. So this looks a little bit off from 3 to me, right? I mean, maybe it's my eye. Maybe that's the problem. Maybe it looks exactly on 3, but my eyes are crooked. But this looks a little bit greater than 3 to me, right? 3 looks like it would be about there, or at least here. Anyway, we're gonna estimate that. And when I said 3, I was really meaning negative 3. Okay, so we're gonna estimate that at negative 3, and then the other one is going to be at 3. And y will be equal to a positive 3. Okay, so those are the two vertical asymptotes. And I should have introduced that there's two types of asymptotes. There's vertical asymptotes, and then there's horizontal asymptotes. All right, so we have two vertical. So y is going to be equal to negative 3. And, oh, I did screw that up. I did. That should be x. X. Even still, right? Doing this over a decade. And still, it's hard for me to remember that a vertical line has an x equaling a number, right? Doesn't it? Every, bone in my body just wants to say, it's an x value. It's a y value, I mean, because it's vertical, right? But no, it's an x value. The x is what's constant, okay? So I understand. Listen, we all struggle with mostly the same things, all right? But the thing is, you keep practicing, and you minimize the chances of mistakes. Everybody's human, though. Everybody will make a mistake. I make mistakes. You make mistakes. We all make mistakes, right? Or as Bob Ross says, we all make happy accidents. Oh, I love that guy. Anyway, if you don't know who I'm talking about, search him up. Watch one of his paintings. So the horizontal asymptote now. This is where it approaches. There's basically horizontal asymptotes, on the y now equaling 0. But whenever you have a horizontal asymptote with y equals 0, you can kind of just ignore it. It really doesn't help us. We don't need to do anything, let me put it that way, with the formula. All right? So now let's start creating the formula, because those are all the pieces we need. So remember, a rational function will have some function on the top, call it g of x, and some polynomial or function on the bottom, call it h of x. So first, the vertical asymptotes. They are going to give you insight into what expressions you should be writing in your denominator, okay? Because if you notice, this function on the graph here never obtains an x value of negative 3. In other words, when the function approaches negative 3, something weird happens. Okay, you get an undefined result. Now, the only way you can get a fraction here with an undefined result is if the denominator is 0. Okay, 0. So that's what I'm going to look to do. I realize I have two vertical asymptotes, so I'm going to have two factors. Now all you have to do is figure out what simple expression, x plus or minus what, if I were to plug in this for x, would give me 0. Well, it turns out that if I wrote x plus 3, right? If x is negative 3, and I take that and plug it in, this whole thing is 0. And then 0 times whatever the heck this thing is, it doesn't matter, it's 0. That would give a 0 result in the denominator. And then same thing for this, you would just basically take the sign and flip it. All right, that's the kind of easy way to do it. Just take the signs of those vertical asymptotes and just flip them. So that takes care of that. Then we go to the numerator, okay? And we're going to focus on then the x-intercept, because what happens here when the function is at the x-intercept, we know that the x value is 2, or roughly 2, and the function's value is 0, 0, right? So what will give a result of 0 if you have a fraction here? What do I need on the top? Right, I need a 0, right? The numerator's got to be 0. So the same way we approach the vertical asymptote, I'm going to approach now the x-intercept, but in the numerator. So if x is going to be 2, then you're going to write x minus 2, because if x is 2, when you plug it in and you subtract 2 from it, it becomes 0. It's simple, right? So nice. So now, last but not least, your y-intercept. You save this for the end. Now the y-intercept, it's telling us that when the functions, when you plug in a 0 value for x, the function's value should be negative 2. So what you can do now is, since you have a lot of the pieces, you plug in negative 2 for your function value, and you plug in 0 everywhere you have your x's, okay? So what's going to result then is going to be something like this. It's going to be 0, 0 minus 2, all over, 0 plus 3, and 0 minus 3. And that's going to then simplify down to, that's going to be negative 2 over negative 9. You can get rid of those negative signs, right, because they don't really do anything. Well, not that they cancel. They do something, right? But double negative, they cancel. I don't know what I'm thinking. But if you notice, does the left-hand side equal the right-hand side? No, it definitely doesn't, right? So what you have to remember is when you're talking about your y-intercept and how to incorporate it, what you're going to be doing is you're going to be placing a coefficient here in the front. And what you're doing is you're really then solving for this coefficient that will make this equation true. Because you know, that's what the graph says. You know that when x is 0, y must be negative 2. But if I don't plug in any kind of coefficient in there, then it's never going to be true. All right, so that's why we kind of need that coefficient. So kind of multiply then the right-hand side by the reciprocal, right? That's just the algebra. Whatever you do to the right, you better do to the left. All right. And remember, this is really 9 halves multiplied by negative 2. All right, so the 2's would cancel, leaving you with negative 9. And that's your c value. So now what you're going to do is you're going to go back to your original function, and you're going to then plug in your negative 9 there, okay? So just plug in the negative 9, and you're done. You're done you're just plugging that in where that coefficient was. And you're finished, all right? If you wanted to clean up the denominator a little bit, you can FOIL it, right? You could leave it that way too, but if you FOILed it, it would be x squared minus 9. It's a perfect square. That's probably the way you're going to see it. But that would then be the function. Now you can just check yourself if you want. Go to your calculator, go to y equals, and hit negative 9 times, all right? Now keep the numerator together. You need the parentheses here in the numerator, x minus 2, and then divide by, and again parentheses, because you need to keep the numerator and the denominator together, all right? But yet distinct from each other. So you always want to plug in everything in the numerator with parentheses around it, and then same thing with the denominator, okay? Hit graph, and lo and behold, right, lo and behold, look at this picture. The graph matches beautifully to the graph I have on the screen. Well, both of them are on the screen. The one over here. The one on the upper left matches with this one. If you can watch my cursor as you go bug-eyed from trying to keep track of it. But that's it. All right? So as you can see, it kind of works out nicely. It's not that hard. It's just a series of steps we got to follow. But hopefully, not only do we know the steps now, but we understand why we're doing it. Don't just learn something to learn the steps. I mean, there's certain things you kind of have to, there's certain things that you do need to just simply learn the steps. But you always want to look for the why behind it. Why am I doing this? Why do the vertical asymptotes, give me the factors of the denominator instead of the numerator, right? What do vertical asymptotes imply? The x-intercept, why is that in the numerator now? All right? Because the more you understand why, the better problem solver you're going to be. And keep in mind, the whole goal here is to do better on your exams, right? And maybe to become a mathematician, I'm not sure. But I would imagine most of you here are pursuing, let's say, other career opportunities other than mathematics, right? I know, I can hear you screaming at the screen right now. I can hear it. Of course, I hate this stuff. I know. It's just think about it as it's a means to an end, okay? It's a means to an end. You have to do well here, though. You got to kind of jump through the hoops, all right? But stay determined, stay focused, don't give up, All right, remember, the only person that can get in your way is you. Don't give up. Keep going. And we got your back, by the way, because we have thousands of videos, not only here in math, but chemistry, physics as well. We'd love to help you with more stuff. All right? Take care.